back to Chem Talks. Has anybody ever called you dense? When they called you that, was that meant as a compliment, or kind of were they slamming on you a little bit? Well, today we're going to talk about density. And this is not a sneaky way of asking are you dumb or not. No. Density is a physical property of a material. Remember, we've talked about physical and chemical properties and changes already. Today we're going to investigate one of those physical properties in a little more detail. So go ahead and follow along with me, please. Let me start off by asking this simple question. Why does ice float? After all ice is really cold water. So if we're mixing water with more water, shouldn't they just mix together rather than float on top? Now picture an iceberg, right? Granted, a lot of it's underneath, but it does still float on top. Or how about that ice you put in your water to make it colder? Why does the ice float on top? And the answer is density. Ice actually has a different density than liquid water. And it's one of the unique properties of water is that when ice freezes, it actually gets less dense. This is different than most substances. So as the density changes, it causes the ice to float on top. So let's go ahead and investigate density in a little more detail. First of all, we said that density is a physical property. Well, actually, we can say it's a quantitative, intensive physical property. By quantitative, means we can place some numbers with it. We can actually figure out the density of a substance, which we will do today. Intensive means that its density doesn't depend on the quantity of matter. Whether we have 100 grams of it, 1,000 grams, 10,000, a million grams, the density of that is always going to be the same. And as we said, physical property means that we can look at this property without altering the substance of it. So if we take a piece of metal, break it in half, we can still figure out the density, and it's going to be the same. We still have the same metal at the end as we did at the beginning. So we can define density as the mass per volume of an object. Okay, basically it's a measurement of how tightly packed the molecules or atoms are within a substance. The closer they are packed together, the more dense it is. Let's take a look at this example. We look at same volume, same size, but look at this only has a few particles. This one has a lot of particles. So we'd say that this one on the right here is more dense than the one on the left. Pretty easy concept to grasp for you, I hope. So let's look at the equation for that. We said density is mass per volume. Generally, we're going to measure the mass in grams and volume in either centimeters per cube or milliliters, depending on whether it's a solid or liquid. So if we write this out in equation form, D equals M divided by V. Okay. Well, let's talk about how mass is the amount of matter in an object. Remember that? How we defined that earlier? Okay. Volume is the amount of space an object takes up. And we can find volume a couple ways. If it's a regular shaped object, we simply take the length times the width times the height. So length times width times height will give us our volume. And that's how we get centimeters cubed. Now, if it's an irregular shaped object, okay, we can't really measure it easily. So what we're going to use is the water displacement method. I think you probably have done this already. Say we have an object, okay? Put some water in, say, a graduated cylinder. We drop our object in. Well, when we drop that object in, the volume of the water is going to rise. And the difference in volume from here to here is going to tell us the volume of that object. Okay, so this is called the water displacement. We use this with things that are irregular shaped. As I said, we're going to measure our units for density are going to be grams per milliliters if we're dealing with a liquid, or grams per centimeter cubed if we're dealing with a solid. Now I'm going to give you the magic equation. There's two equations, or two things that you really need to know about density and water. First of all, for water, 1 milliliter of water is equal to 1 centimeter cubed, which is equal to 1 gram. This is kind of what the metric system is based off of, why it makes a little more sense in English. But this is what I like to call the magic equation. You will have to have this memorized, so make sure you get this written down. The other thing that you'll have to have memorized for the water is the density of water. And it's simply 1 gram per milliliter, meaning 1 gram of water occupies 1 milliliter. 1 milliliter of water will weigh 1 gram. So make sure you have both of these in your notes and memorize. Okay, let's talk about how we do our density calculations. We said density equals mass divided by volume. So what we use, and hopefully you've seen this before, is what we call the density triangle. Density is equal to mass divided by volume. And how you use this is this. You're going to cover up whatever unit you're looking for, and the other two units are how you're going to solve it. So when we're on top, one variable on top of the other means divide. When they're side by side, that means multiply. So if you use this, it'll help you to know what to do each time. So density, to cover up density, we're going to have mass over volume. If we want mass, it's going to be density times volume. And if we want volume, it's going to be mass divided by density. So these are the three variations of the density calculation that we can easily figure out by using our density triangle. So let's try a couple problems. First problem here. A gold bar has a mass of 11132.43 grams. I know it's a weird number, just go with me on this. It is 9.6 centimeters long by 7.25 centimeters wide and 8.5 centimeters thick. So calculate the density. So density, remember, is mass divided by volume. We pull up our density here, right? We get rid of density, it's going to be mass divided by volume is how we do it. Well, the first thing we have to do is figure out volume. So remember, it's a regular shaped object, so our volume is going to be length times width times height. So we have 9.63 times 7.25 times 8.5, which gives us 576.81 centimeters. Now density is mass divided by volume. We had a mass of 11132.43 grams divided by our density up here, or excuse me, our volume up here, and we get a density of 19.63 grams per centimeters cubed. Pretty easy. Okay, for problem number 2, I'm going to have you try this one on your own. Let me give you the problem, and then I'm going to have you pause the video, work out the problem on your own, and then once you have it done, come back and see how you did. So the question is this. Mercury has a density of 13.6 grams per centimeter cubed. What is the mass of 95 centimeters cubed of mercury in grams? So we're looking for the mass. We're given density here, 13.6, and here's our unit of centimeter squares. Remember, that's volume. So we have volume and I have density. I want you to figure out mass. So go ahead, pause the video, and then when you got it figured out, hit play again. All right, did you figure it out, or did you just let the video roll? If you just let the video roll, pause it. At least set the problem up. If you don't have a calculator with you, that's fine. Set the problem up to make sure you are doing it correctly. So pause it, hit play when you're ready. All right, hope you didn't cheat. So we're looking for mass. We get rid of mass. It tells us mass then is equal to D times V, density times volume. So I'm going to take 13.6 grams per centimeter cubed, times it by 95 centimeters per cube. And what I'm going to see happening is my units of centimeters cubed are going to cancel each other out. And we'll talk about that a little bit later, more in depth on why those are canceling out and how they are. But the important thing to know is the units we're going to be left with is grams, which is our unit of mass, which is really important. So we should get an answer of 1,292 grams. Did you get this? I hope so. Now, number 3, I'm going to have you do this totally on your own. Here's the question. What volume in centimeters cubed would a chunk of ice occupy that weighs 1,250 grams? So pause the video, work this out, and then remind me about this in class, and we will go over it to make sure you did it correctly. I don't want you to cheat and do it here. So do it on your own, bring the answer into class, and we'll go over it. So the last thing I want to talk about is density in liquids. And let me start off with a question for you. What happens when you mix oil and water? Let's say Mom made a really greasy casserole. You put it in the sink to wash it, put water in there, and what do you see happening in that dirty casserole dish? Well, it's probably something like this. You get layers. You get an oil layer, a water layer, maybe you get this really cool sheen, these colors coming from the oil. Well, the question is, why is this happening? What we see is this. If you pour liquids together that don't mix and have different densities, they're going to form these different layers. Well, why the oil and water not mix? Well, that's something we're going to get into later in the semester. We're not going to worry too much about it now, other than let me say they have different polarities, which prevents them from mixing. But what we see when these layers form is that the layer that has the highest density is going to be on the bottom. Think of it as heavier, sinking to the bottom. And that which has the lowest density is going to be on top. So let me ask you this. In that example with the water and oil, which one is more dense, the water or oil? Think back to the picture. What was on top? The oil was on top of the water. So the water is more dense than oil, which means that oil has to have a density of less than 1 gram per milliliter. So that's the density of water. Check this out. Look at this example in the beaker here. We have water, oil, and in the middle we have a super ball, kind of like you get out of the gumball machines. So the question is, what's going on here? Well, objects or substances with more density will sink below objects or substances with less density. So if we look at this picture, how would you rank these from lowest to highest density? Well, look at this. We know that the oil is less dense than the water because it's floating on top of it. But if we look at the Super Bowl, where is it? Well, it's trapped between the oil and the water. So that means its density has to be somewhere between that of water and oil. It's kind of cool how the water just sits on top of there like that. Now, we can have the same thing happen if we have multiple layers of liquid. If you have two or more substances, what you'll see is that once again, the more dense substances will be in the bottom, where the less dense substances will be on the top, and you get this pretty density column. This is done with colored liquids of different densities, but we'll do a similar thing to it in class. So one last thing for you to ponder. Let's say we had an ice cube floating in a glass of water, and that melts. What's going to happen to that water level? Is it going to rise, or is that water level going to fall? I want you to think about this and come up with an answer for class. And not only be able to give me your answer, it rises or falls, but explain that answer. So think about it, write a note so you can answer this in class when we get there. All right, guys. Today we talked about density. Remember, density is the mass per volume of a substance. It basically tells us how close the atoms or molecules that make up that substance are packed together. Remember, it's mass divided by density. We use the density triangle to figure out all three of those variables. And then we also learned the magic equation for water, and that was that 1 gram of water is equal to 1 milliliter of water, which is equal to 1 centimeter cubed. You have to have that memorized, along with the density of water, which is 1 grams per milliliters. So like always, guys, if you're having any problems or any questions, please come see me before class so we can get you straightened out. Otherwise, take care, guys, and I'll see you in class.